Welcome back, Pre-Calc. We're continuing with 3.5, and we're going to do more of a graphical numerical approach with these problems. And remember, with numerical, so yes, they give you the equation, but what they're asking you to do is just look at the graph and answer these questions. So as you look at the graph, as x approaches negative infinity, what they're asking you for is we're going infinitely to the left. What are we getting closer and closer to? And the whole premise to this is that we're getting closer and closer to the horizontal asymptote, either on the left side of the graph or infinitely to the right. And that'll change a little bit when we get to calculus. Just so you're aware, it's possible to have more than one horizontal asymptote. You don't have to approach the same value on both ends. It just happens to be this way on rational functions. So that's the end behavior, approaching infinity or negative infinity. So these are your clues. Let me highlight it. These are your clues about the horizontal asymptote. All right, so let me just change colors and talk about the next one. As x approaches 3 from the left, so looking at 3 on the left side, we're looking at the whole is getting closer and closer to 7/5. And I only know that because of this. I didn't do any work with the problem. They told me the whole was right here. Now we could have figured that out by factoring. And if you factored it using all of our tricks that we've talked about, if it factors, then that needs to be on top and bottom. That means the x minus 3 needs to be on top and bottom. And then what's the other factor? X plus 2. Let's see, this would be 2x and 1. If that's negative, this one has to be plus. So if you plugged in 3 in for these x's, 2 times 3 is 6 plus 1 is 7. You get 7 in the numerator. And 3 plus 2 in the denominator gives me 5. So those two pieces cancel. So it's the same on the left and the right. So when this, let me change highlighters, when this is the same value, and it's a number, not infinity, because infinity deals with the horizontal asymptote, and they approach the same answer on both sides, we're looking at, go back to red, a whole. This is your indicator that you have a whole by looking at that approach. Now let's look at -2 on both sides. Let's change colors again. -2 on the left side is looking at this graph, is going infinitely up. The function, that means up or down. Up is positive infinity. Whereas the right side of that graph is going down, so that's infinitely down. So the key to this is when, let me switch colors again, this is a numerical value, not infinity, but these two are infinities. Both positive, both negative, or one's positive, one's negative. That's your clue that you're looking at a vertical asymptote. So you don't need the graph, you don't need the equation to be able to answer these types of questions. That's the point I'm trying to make. Now you probably want the graph to answer the domain and range. So by looking at the graph, you can say, oh, okay, well, it goes from negative infinity infinitely to the left until you get to -2. And then from -2 until we get to 3, and then from 3 to infinity. And then same thing with the range. You want to look at the y values of the wholes and the horizontal asymptotes. So that's where we want to examine 7/5. And then from 7/5 until 2 from right here. And then from 2 to infinity. So you don't actually need the graph for the record. You could just look at these values to help you indicate that. So maybe I'll take a step back instead of explaining so much about the graph. You need to look at one of these two, whether it's the equation or the graph, but then be able to answer these questions. But again, notice that they give you the whole, the location of the whole, because that'll probably be used down the road. So as a reminder, these first two pieces, x goes to positive or negative infinity, that's basically just saying what's the horizontal asymptote? Well, look at your graph, or Exponents are the same, so divide your leading coefficients. 1 divided by 1 is 1. And for our purposes in pre-calculus, these numbers will be the same. As x approaches -3 from the left, we'll figure out where -3 is. Or look in your directions where it says -3 is the whole. It's going to approach the same value on both sides. So that's your indication that that's the whole. So 1 from the left. Now, this is important that you get this correct. 1 on the left side is going down, so it's -infinity here. And then 1 on the right side is going up, +infinity. But because we have infinite values there, that's your clue that that is your vertical asymptote. So again, I want to point out that you don't actually need the graph to answer the domain and range based off of all the clues. It's just helpful. So the domain, your x values from -infinity to -3, -3 until we get to 1, and then from 1 to infinity. And then the range, look at where you have a horizontal asymptote or the y value of the whole. The one that happens first is 1/2, the y value of that whole. And then 1/2 to 1, the horizontal asymptote, and then from 1 to infinity. So again, pause the video if you need to practice this, understand it, see if you can even try this next one on your own, see if you get the same answers. Might help you even get through these notes a little bit faster, because you could fast forward if you see what I get as my final answer. So again, this is your clue as x goes to positive and negative infinity, that's your horizontal asymptote. As you look at that, it's both 0. Why is it 0? The degree is bigger on bottom. So if you remember your Bobo rules, bigger on bottom, y equals 0. -2 on the left side. Well, if you look in the graph, you can see there's a hole there. You can confirm that it's a hole because the directions tell you it's a hole. And you could also figure out by canceling out. So just a reminder, you can piece all of this together. Factor the denominator. And you can see the canceling factor is at -2. So that is confirming that we have a hole there. And then this one you'll see is a vertical asymptote. On the left side it's going infinitely down, so that's -infinity. And then on the right side it's going infinitely up, it's positive infinity. That's a terrible infinity sign. Don't judge me. And now we have enough to state the domain and range. X values are not defined at -3 and -2. Trying to squeeze it in there so you can see it all. And then the range of the y values. The horizontal asymptote happens first, and then the whole happens. Notice that we write it in interval notation, and these values in here, let me highlight, these values, the order depends on what happens first. I think the previous one, the whole happened before the horizontal asymptote. So pay close attention to that, because I will mark it wrong. And again, feel free to pause the video or try these on your own. It's just repeating itself over and over again. So as you get better at this, you might just look and say, okay, horizontal asymptote. But, exponents are the same. Divide your leading coefficients. Piece it all together. -2 on the left side, that's your whole. Happens to be -1. -1. It tells you in the directions. You can also see it on the graph. So again, that's your whole. So then the other one is going to be our vertical asymptote. Left side of -3 is going positive infinity, and the right side of -3 is going down, so it's -infinity. And now you can answer those questions from -infinity to -3, -3 to -2, and -2 to infinity. And then the range, now the whole again is happening before the horizontal asymptote. And if you're still not getting it, I would suggest writing down what your specific questions are so you can come to class and ask those. So this is basically just filling in things. I think the page numbers are off though. Just look at the last 2 pages and try to answer these questions. So if we have a numerical value, so a is not infinity, and he wrote it backwards. I don't know why he did it this way. But notice it's x goes to positive or negative infinity. That's what we're looking at, the horizontal asymptote at x equals a. I said that wrong, at y equals a. Horizontal asymptotes are horizontal lines, so they better be in y equals form. So now if the function goes to b as x approaches a from the left and right side, then it's a hole at the ordered pair a comma b. Again, he wrote it backwards. I hope that's not confusing to you, where he wrote x goes to a second, as we typically write it the other way. And then if the function goes to positive and negative infinity, again, you can both be positive, they can both be negative. From the right and left side of x approaches a, that is your vertical asymptote at x equals a. So far, what we've been able to do to state the domain of rational functions is setting the denominator not equal to 0 and solving. Now the range, so far we haven't really done, we've looked at the graph is what we've done. Maybe I can write that up here, or look at the graph. So I'm going to write that as well for this one. You can look at the graph. But another way to think about it is the range are undefined values at the y value of the hole and at the horizontal asymptote. So you probably noticed that when we write the range, we just write it out and we skip over where the y value is of the hole and the horizontal asymptote, which is also the same way as looking at the graph. So instead of rushing through this, I think I'm going to stop the video here. I have quite a bit to catch up on, and I'll see you in the next video.